So far, we've learned the basics of object-oriented programming. We've learned how to put what is an object, what is a class, how to put them together. We've learned a bit of the characteristics of object-oriented programming with regard to the design, how to design it, so on and so forth. Today, we're going to focus on UML diagrams. What are UML diagrams and how we can utilize the UML diagrams to bring the systems we'll develop into life. That is our main aim today. So our main aim is to look at UML diagrams and how we can bring them to life. UML diagram itself, or the word UML diagram, when we say what is a UML diagram, then we are saying that the UML diagram stands for Unified Module Language. Sorry, it stands for Unified Module Language, UML. And it is, give me 1 second, okay? Sorry about that. So UML modeling language is the standardized visual language used in software engineering or modeling system softwares. UML provides a way for us to represent a software's architecture, its design, its implementation, and ensure everyone involved can understand and communicate about the system clearly. We use the UML diagram to convey a particular message, depending on your audience. So depending on the audience, I want to convey a message about the architecture of the system I'm building. I want to convey a message about the design of the system I'm building. I want to convey a message about the implementation of the system I'm building. I would use a UML diagram to portray that. Again, the reason why we call it the unified model language is because it is visual. It doesn't matter if you know computer engineering or you know structural engineering or you are just a programmer or you are the system analyst or you are the database design or maybe you deal with data science or something. Whatever you deal with, once you see that diagram, you should be able to understand because there is a flow, there is a direction, there is a way in which that diagram looks like and it conveys a message to you in the simplest way. For you to understand, okay, this is what we want to do. Let us carry on doing that. Or this is what we want to do. Let us push forward and do that. So that is why we are learning the UML diagram, first of all. For today, UML diagrams can be broken into two halves. We have the structural and we have the behavioral. The structural form of UML diagrams comes from the structural form of UML diagrams is where we find what we are learning for the course. That is the class diagrams. So here we have diagrams like the class diagram, we have the structural diagram, we have the behavioral diagram, we have the interactive diagram. All of these are diagrams that we can find in these cases and then we use. In the structural diagram, we can see we have classes, we have components, and we have deployment diagrams. Over here, we can see normally we add the composite structure and then the package. So these are words in which we'll be learning and then we'll be using as we're going forward. When we talk about the behavioral diagram, then we are talking about use case diagrams, we are talking about sequence diagrams, we are talking about state charts, we are talking about activity diagrams. So these are diagrams in which we would have to know when we come to the behavioral. Before we get there, let's talk about them in a broad nature. When we say structural and behavioral, what do we mean? When we say behavioral, we are looking at the system from the point of view of what the person is going to do and how he's going to the processes in which the person is going to do in the system, or the business processes that are going to be utilized in the system. There we are looking at the behavioral. The structural, we are looking at the individual entities, the individual structures, how they move from one point to what they do, what they keep, how they interact with someone else. That is what we are looking at. But under behavioral, we are looking at what can you do? When you get something, what will you do? How will you do it? Things like that. That is what we'll be focusing on in those kind of diagrams. Now, we've spoken at length to what a class diagram is. We've spoken a large deal of what is a class diagram. We're just going to go over it again a bit and then move on to the other concepts that we are supposed to learn. So, a class diagram. The classes are broken down into classes, interfaces, and collaborations and relationships. We will look at each one practically very soon. But the class is broken down into three structures. We've seen this. First structure, the name of the class. So we have the square, then we have the name of the class. For example, here, our class is called account. So over here, using the laser pen, I can see that it is called what? Account. So I have an account class over there. Here, I have the attributes, the characteristics. What makes that thing a thing? So when we say an account, we can have the account number, the account name, the initial deposit, the current current balance, so on and so forth. All of those words make something an account, hence we call them the attributes. Then we have the actions the actions that class can perform. For example, we have add an account, set account balance, get account balance. Note something here, very important. If it is an action, then it has these parentheses beside it. The parentheses can have something in it. For example, here we have set balance. And then in here we have a semicolon account, which means that in here, for you to set the balance, you have to pass through something into that activity called account. So you need to know the account that you want to set as balance. Also, we have get balance. And it is also telling you that once you use get balance, what you would get is the amount in which the person is trying to showcase. So at the end of the day, the thing that will be displayed to you would be the amount the person has in his balance. So here it goes into detail to tell you what is there. For the first one, it doesn't go that much into detail. It just gives you the parentheses with nothing in it, which means nothing from the external environment is being added to that activity for it to do its job. It doesn't need anything from the external environment. Over here, it needs something from the external environment in order for it to do whatever it has to do. I can give you a practical example of this, and then we can see how it would run. Note, over here, the account name is always, the name of the class will always start with a capital letter. As a rule, all classes start with a capital letter. So if you have code from someone and you're looking at the code, you know nothing about programming. The moment you see a capital letter, that should tell you that what that person has written is a class. Hence, conventional means all our class names will start with a capital letter. Number two, the attributes. They are what we call variables in programming. So whenever you have a variable, that thing there is an attribute of a particular class if you are coding in object-oriented language. Key point, if you are coding with object-oriented language, then our variables are always going to be the attributes of the class. Now, the last point, the operations. There is where we have the methods or the functions. In Java programming, we'll call it methods. In other programming languages, they'll call it functions, but both of them do the same job. Their job is to have a particular set of instructions that would be called upon to execute and go away. So if I call add account, the moment I call add account, there is a set of instructions I have put in place. There are a set of rules that I have put in place. And once these rules are called upon, they will be executed and they would go away. So the moment I say add an account, probably I would ask for the person's name, surname, first name, all of those things, and then do them. I don't really care about the set of things I will do at this point in time. All I know is when I have an account and I say add an account will be added. How it will be added, we'll think of that soon. But there is a set of rules and principles I have put in place so that when I call add an account, those set of rules and principles will be called upon and executed. That is what we call a function or a method. So here, if I ask you to draw a class diagram for me, this square box here is an entity. It shows me the class, what the class has, what information it contains, and so on and so forth. Down here, I have a square and I've put in bank, and I have a square and I've put in customer. When I do this, I am no more creating a class block, but I'm just creating an entity. So the thing on its own. So for example, if I replace the word bank here with account, then I've created an entity called account. In this case, I've created an entity called bank. Or here I've created an entity called customer. It is just the square with tells you, oh, this person is an actor in my environment. He belongs there. As to what information we keep, the attributes, what can it do, the operations, we have not specified that. So all we have is the name of it. So you can see bank here and customer here. When I call something a package, that means that I have given it a set of individual entities in which I have specified the rules they have. Let me rephrase that again. If I determine something in which I am doing is a package, it means that in that thing, you would find multiple classes there, number one. They would be connected together, number two. And I am bundling them all up because they are about the same thing. For example, let's say because I live in Teshi, so let me use Teshi as an example. In Teshi, when I go there, I would see Treeblow, I would see Greater Estate, I would see New Estate, I would see Teshi, Mami, all the names in which you can find there. If I group all of them together as one, the word Teshi, which governs all of those provinces, becomes my package name. That is, all of them together are Teshi. So if I say Teshi, let's say Treeblow, that is what they've done over here. So Teshi, Treeblow. So when you go into Teshi, go and look for Treeblow. So I'm grouping all of the classes into one and keeping them in the same place so that when I need to call upon them, I know that, oh, let's say I have, for example, you have two places that have the same name. So let's say you have a savings account and you have a checking account. But you have savings account for premium customers and you have savings account and checking account for VIP customers. You treat these two accounts very differently in your bank or whatever institution you have. So if I say savings account, right there is a problem, because which of the savings account am I talking about? Am I talking about the premium or am I talking about the VIP? So I can create a package for premium so that I can say premium checking account or premium saving account. And I know that, okay, in the environment of premium, I have a checking account there and I want you to use those rules to work on your environment or handle the things you want to do. I can also go VIP package, and in there, I would see a class called savings and checkings in which I can use. So when I want to group my packages, oh, sorry, I want to group my classes together so that I can easily identify them as, okay, in my bigger environment, this is also a smaller environment in which I've created, then I would utilize the word package. So far, are there any questions?
Yes, sir. I'd like to know if all classes will necessarily have to have an operation.
You want to
Or
know
just
if all what?
all classes
Mm-hmm.
have to have an operation.
If all classes have to, then that last word is what I'm not hearing.
Operation. Right?
If all classes have to have an operation, yes,
Have to
all
perhaps
classes has to have an operation. The operation there, oh, let me rephrase. All classes have to have an operation. Will all classes have an operation? No. Or let me say it in a better way. I'm using the wrong English here. All classes can have or an operation. Not all classes will have, but that avenue for operation is always there. For example, there are some times in which you just create a class and that class will just have a storing of information. So maybe you want to store the name and age of something, so you just keep it there. That's fine. That means that that entity will do nothing in the organization. But you see, it is very difficult for you to write a class that has no operation. Because if you are going to use the principles of object-oriented programming, that is, it must have encapsulation, must have abstraction, must have polymorphism, it should be able to inherit. If you are going to use these principles in what you do, then whatever happens, you have at least one or two operations in your class. But is there a scenario where you can build a class that has no operations or no functions? Of course, it is possible. Let's see an example of this. In here, I'm going to show you a piece of code in IntelliJ. So here I've projected a piece of code in IntelliJ. In the IntelliJ, in the IntelliJ, I have created this application over here. In this application I have over here, I have account, checking account, savings account, and main. As a rule, all programs must pass through the main function. All programs must pass through the main function. So the main function is always going to be there, no matter what we do. In the account function here, I have the following. I have the total accounts, I have the account holder name, I have the account number, and I have the balance. I have the balance. When I go to check on the operations, I can generate an account number. I can, this is a constructor to create the class. Over here, I have created a function to add a deposit to my account. I have a function to withdraw a deposit from my account. I have a function over here to transfer money to my account. And over here, I have a method to go and get the total number of accounts we have. And I have another function here to go and get the account holders that we have in our system. Okay. Now, this here shows you the implementation of the account in which we created earlier. I can see the following from this picture here, that on there, I have the name account. So on the system, I have the name account. Remember, it always starts with a capital letter. So I have account over here. Then, what are the attributes of account? What can you say? Okay, if you come to my bank, for you to have an account, these are the information we keep about you. Remember, if we do not keep this information about you, then in our bank, you do not qualify to have an account. Remember, you see, there are some certain words I use, and later on in the course, we'll start learning about requirement gathering and how can we identify requirements and things we need to build a system and so on and so forth. Everything we do is based on the environment. That is based on where the application will work. So if I do not tell you it is based on this environment, and I just tell you, okay, how do you do this? Generally, I am wrong because my system will not work everywhere. It will just work based on a particular environment. So based on my environment, we are saying that for you to have a bank account, we need these pieces of information about you. We need you to tell us the total account. We need to tell us the balance in which you have. And we need you to tell us the account number that we keep on you. So this information here is what we keep for you to have an account. Now, in the slide we are using, so over here, when I come back to the slide we have over here, all the things I just said are the attributes. Of course, for the programming language, there's a way you would write the attribute. If it was Python, there's a way I would write the attribute for Python. That is not the problem of this of contention here. The problem of contention here is I need to be able to identify that for this particular class, this is the name of it, and these are the things that make it, or information we keep about it, or the characteristics we have about it, or the attributes that form that particular name, that's that particular class. So for our purposes, again, these are what we call the attributes. Now, in my class, again, there are operations I can do. So you can see that whenever I say generate account, so this is an operation I can do. It doesn't mean that when I say generate account, something would be done. So you can see that in the coding which we have over here, when I say generate account, it will return the total accounts plus 1. So it means that when I say generate account, it would go into total accounts, look at how many total accounts you have over there, add 1 to it, and save it onto itself. That is its job. But over here, all I'll do is write generate account. The processes that go on over here would be discussed later and would be discussed in the behavioral diagram or the activity diagram or one of those diagrams later. But for now, I am forming the surface of my system. Who are the people who work in my system and what can they do? In my system, the person who works there is an account. And what can you do with an account? You can generate an account number. As to how the account number would be generated, that whole process, that whole business process will be discussed later. In my system again, apart from me being able to generate an account, I should be able to deposit money into my account. I should be able to withdraw money from my account. I should be able to transfer money from my account. More so, I should be able to get the total amount of money, get the total of total bank accounts we've created, go and retrieve anybody who has an account, his account name, and we can also go and retrieve somebody who has an account of versus account number. So these are the actions we can perform. Question a student will ask, sir, why is it that the actions we have here, these actions have nothing in it? And then these actions, when you write them in the circle, they have something in it. Now, let's use our imagination for a second. We are saying that these actions are a set of instructions that are there that will call upon to work. That means that this whole thing we have here and there and all of those places, they are a closed box. Nothing comes in, nothing goes out. So if I call on you, do what you have to do, go away. If I call on you to go and get me the total account, you go get that information, give it back to me, and go away. If I want you to transfer money, I want you to do what you have to do and go away. But if I want you to transfer money, let's say even in Wamumu, if I want you to transfer money to someone, what do you need? You need the person's Momo number and you need the amount of money you want to transfer. So when I call it to come and do what it has to do, it needs some information in order for it to complete its task. There is where this parenthesis comes into play. That means that if it is empty, it does not require any additional information to complete its task. When it is not empty like this, it means that for you to be able to complete your task, you need to have the person you are sending the money to, his account number, and the amount of money that you are going to be sending to the person. So if you do not have the person's account number and you do not have the person's amount of money you want to send to, how can you do a transfer? Another student who is very observant will realize that when I got over here, I saw this account here and I saw this account here and I did not copy them. I skipped them and went to copy deposit. Why didn't I copy the account? I didn't copy it because it is starting with a capital letter. Now wait, anything that starts with a capital letter in about 15 minutes ago, I said that anything that starts with a capital letter is a class. So what is a class called account doing in a class called account? Now, in the class name we see here, we can see there are no parentheses over here because the class is just the rules that govern that thing. So there is no need to introduce any information from the outside. So there is no need for that parenthesis. But in it, we can see that when we have account here, we have some parentheses over here. That means that this is not a class. Because of the parentheses, it becomes a constructor. And it is that word that we discussed at length last week. But I have a class called account. The class is me giving the rules that govern that thing. So when I give the rules values, then I will create an object. So here I've created an object AC1. Why is the object AC1 something? It is something because I have given the rules something. So over here, if I scroll up here and I say the total number of accounts we have is 3. Over here, the account holder's name is, let's say, John. Over here, if I say the account number is, let's say, 111, if I say the person's balance is, let's say, 20,000, then I have created an object from the class account. So the object is me giving the rules values. Now, when I give it values, I can't just give it values and let it hang in the air. So I have to put it in a container that can group and hold all of those values. That is where the word AC1 comes in. So when I say AC1 dot balance, it means that in AC1, I have stored something in balance. Go and give me that information that is in balance. I can't say account.balance because account.balance, the balance there, I have just defined that, oh, when you have an account, there will be a balance in there. But the moment I create an object called AC1, it means I have given values to the areas that are in the class. Hence, I can now use them. That is why I can bring the dots and things in there. The question is this: how do I move from having a class to having an object? And there is where the word constructor comes in, because it is the job of the constructor to construct the object from the class. That means every class you have will have a constructor in it. The job of the constructor is to build the class. So practically, if I am looking at this from a practical point of view, because every application you have is supposed to run in the main function, when I go to the main function, I can see I have savings account here. By the way, the savings account is coming from here where it extends from account. I'll get there. But just to show you how the constructor works, I have savings account here. I have an object called SA1. This SA1, it could be any name I want. I could call it Kofi. It's just that I have to call it something which makes sense to what I am doing. I have the new keyword here. And over here, I have a constructor. You can see it starts with S and it is savings account. It is not a class because it is attached with the parameters. And in here, you can see that I have the following: account name, interest, and initial balance. That means that over here, the computer will go and take that information and give it to the places I have saved and use that to build the object that I am looking for.
Hello? Yeah.
In our class, most of the things we will do would involve you drawing the class diagram. Here. In the latter stages of our class, we would see how we can manifest this practically. But in most times when you teach students object-oriented programming and they can't see the manifestation of it, they find it difficult to understand. In here, I have a class. This is the class diagram stage. If I do not add the attributes and operations and I leave it alone, then I have an entity. If you are very observant, last week I drew the entity diagram, and when I was done, I drew the class diagram. The class diagram contains the attributes and the operations. The attributes in programming terms is what we call the variables, and the operations in programming terms is what we call the methods and the functions. If I group multiple classes together as one, then I call it a package. Are there any questions?
Hello, sir.
Yes.
It's Frank here. So, you said during the generation of the account stages, the account, if you instruct the system to generate an account, it always add +1 account +1, but the total account +1.
Mm-hmm.
Yeah. So my question is, I want to find out where is that one coming from? If I have a total account of 10 in my system, and then it generates the total account +1, where is the extra one coming from?
Well, okay. In this scenario I have here, I have not connected my application to a database. Ideally, I would connect it to a database so that, let's say you walk into ABSA or in any bank, there are different types of banks, by the way. So let's say you walk into a bank. Let's say hypothetically, that bank you just walked into has 1,000 employees. Okay. Now, if you walk there and you say, "Hi, my name is Benjamin or Harry or Kujo or McCarthy or Mauli. I want to create a bank account." The bank will say, "Okay, that's cool. You want to create a bank account? That's fine. Let's create a bank account for you." The question then comes in. You would have your name there. Let's say John. In the system, there are plenty of Johns. So let's say you call yourself John Mensah. Hey, if you're a Ghanaian, then the Mensah there is plenty. So now, how do we uniquely identify you? We uniquely identify using your bank ID. For the bank, they say that, okay, since you are the 101st person, then your bank number is 101, 1,001. The question here is this: how did the bank get 1,001? They got 1,001 by knowing that they already have 1,000 there and adding one. Tada, finished. Now, in the system in which we have over here, in which I was showing you, generate account number returns the total account +1. If you can see here, I said the private static integer total account is equal to 0. So when I start running the program, the computer will create a spot for me in memory, because that is what the variable is. And that spot will have a value of 0. So it will create a space in memory for me. When it creates that space, it will have a value of 0. So that that space will not go away, I told the computer to make it static. That means that the computer will have a permanent place for me whilst the computer application is running on my server. That will have something called total account, and in there it has a value of 0. So in here, if I tell the computer, go to the spot called total account, when you get there, increase the value there by 1. That one, it's normal arithmetic. So I'm telling you to increase the value by 1. That one is not coming from anywhere. I am the one telling you that whatever you have there. Note, I may not know what you have there, but whatever you have over there, increase the value by 1. Simple arithmetic. So I'm giving you the 1 to increase. That means that for the first person, I would increase the 0 to 1. So you'll be my first what? Customer. If you are my 10th customer, then I'll increase the value from 9 to 10 because whatever that is there would be 9. And I would add 1 for it to be 10 and store it back there so that no matter how many accounts you create, I'll keep count of who has created an account and when they have created an account. I hope you understand me.
Yes, sir.
Mm-hmm. So the +1 is arithmetic. You are saying add +1, so it will add +1. It's as simple as that.
Okay, sir.
Now, in class diagram, we have something called responsibilities.
Oh, sir, please, I have a question.
Okay, what is your question, please?
Please, let's go back to the class diagram you showed us before.
Okay.
You explained it, but I just want some clarity.
Okay.
So, where we have the package, we have Java, AWT, and then Polygon. And then you said a package is a collection of classes. So I don't get it, but the AWT is in small letters. So is that also a class? How does it work? Please? If you can explain it again one more time.
Sorry, I got muted out, so I couldn't hear you well. You said the one down there is Java AWT Polygon, and you said
Yes, please.
it is a package name. So what is the problem again?
So you mentioned that the package is a collection of classes. Yes, but then the AWT, a class is supposed to start with a capital letter, but the AWT is in small letters. So does the AWT also count as a class?
Okay. So the AWT there is not a class. It is a method.
Okay.
It's a function. So the AWT here, it's not a class, it is a function. So technically, if I'm reading this from a programming point of view, we have class Java. In class Java, you would find a function called AWT. And in the function called AWT, you would find a class called Polygon.
Oh, okay.
So that is
Yes.
what it is. Technically, if you want to bring it to layman terms, packages are like folders. So there are folders that you keep. You see that when I show you, let me show it from this point of view. Okay, so over here, right? I'll right click here, and then I will say I want a new package. And it says I should enter the package name, and I'll call the package, let's say, bank info. Okay.
Okay.
Now you see when I said enter, you see what it created for me here, a folder.
Yeah.
So in this folder, I can put in accounts refractor. I can put in checking account refractor. I can put in savings account refractor. I can create another package name to group my classes. So in here, you can see that all these classes are now under banking info. So it means when I want these now, I'll just say in banking info, go and look for account. Then you can go and look for account for me. So in order to make my programming life easier, for example, if you take, let's say, a university, you have the academic unit, you have the account unit, you have the procurement unit, you have the transport unit. So I can create package accounts, package procurement, package exams, package records, package procurement. Then in there, I'll put the classes that has to deal with them. So that if I am looking for any information and you come and you say, oh, Charlie, the thing that has to do with school fees is not working well. I know that because it is school fees, it will be kept in exams. So when I go to exams, I'll find the thing that I'm looking for that has to do with what? school fees. If I don't do it like that, I'll have everything listed here, and when I'm looking, I can't look well. So the package will help you group and itemize things well. Is that okay?
Yes, sir.
So this is the practical use of a package. But if I want to refer to it, I would refer to it in this format. Again, with the knowledge that everything that is a class starts with a capital letter, it means that here you have a class, a method, and another class. Okay. So classes have responsibility.
Hello, sir.
Yes.
Please, my hand is up.
Hello, sir.
Yes, Kofi.
Yeah. So in the example package you just created, if you can put it, you see the example you had, the Java, the AWT, then Polygon. So if we can call that package the way and then we want to know how the order will be, so that when I look at this example, Java, AWT, Polygon, where will, for example, our package that we've done, if we're calling it in this way, how will it be?
If I don't understand. If
you were describing like the path to the package we've just created, how will it be using the example that you have on the diagram?
Over here, like in here?
No, the example you have, the class
over here.
Yes.
Okay,
so if you are describing path name for package that you just created, in our own situation, how will it be?
Be like banking info. And then here, let's say I want account, so account like this. Is that okay? So the other one will be banking info. That. And then in here I have savings account. That means that here the package is called banking info, and in the banking info I'll find what savings. And here we have a package called banking info, and in banking info I'll find savings account.
Okay, but there's no Java in our case.
No, so it means that this Java here is a package. For example, when I come here, when I come to the code here, I can tell the computer, look very, very well. Look at the top here. Do you see the top here? Can you see it?
Yeah.
You see, it says import banking info dot checking account. Import banking info dot savings account. Can you see that?
Yeah.
So I am importing the package now because they are not all in the same place now. They are all in different places. So it means that now I have to go and import. So for example, here I would say import Java. So there is a package called Java, which starts with a capital J. And when I bring dot, you can see that I can import all the things in the Java package, or I can go and look for selected items in it. Do you understand? So there is Java is the programming language, but they have created a package called Java where you can find the utilities you want to use. For example, in here, if I want to use the utility called the scanner class, so here I have the scanner class. I can see that the scanner class here, after creating the scanner class, I can see that I am importing Java. In Java, I have utility, and in utility, I have the scanner class. Can you see that? So I am now utilizing the scanner class here. So I can create different packages, technically folders, keep things there, and call them in a particular folder I want, so that I can help my grouping, help my naming, make my coding more correctly formatted, and so on and so forth.
Okay, all right.
Okay.
Hello, sir.
Yes.
Yes. Please, can we go back to the codes for creating the account?
Okay.
Yes. Where you define the class for account.
Okay.
Yes, I noticed you have there is a total account which is being increased at any time an account is created.
Mm-hmm.
And now, is there a reason why there is no distractor now? Because as the total account increases, at a point when when an account is not in use and nothing happens to the total account, it goes on forever.
It will not go on forever. And the reason why it will not go on forever is the total account would be generated. Okay. Oh, sorry. The total account is just counting the accounts that have been created. Okay. So it means that it will only be counted when you are creating an account.
Okay. So at
if
this
you are
point,
if you are not creating an account, there's no need.
So at this point, we are not considering the deletion of an account.
No, we are not considering the deletion of an account.
That's okay.
By the way, you will never delete an account.
Okay.
That thing where you go to a bank and they tell you that your account has been deleted is a lie. Oh yeah, they will close it, but they will not delete it. So technically, that account has been created. So that is why you never have the case whereby you go to the bank, they give you an account number, and then let's say you don't use that account number for like 10 years, and then they close the account. And then someone comes and says, I want an account number. Then they'll give that account number to that person. That will never happen. Because no matter what, that account has already been created. So if you are thinking of it in terms of us deleting, so like we have 5 accounts, so let's remove one because this person has been deleted, that kind of drill, no, that will not happen in this scenario.
All right. All right. Thank you.
Okay. So now let's look at responsibility, finally. So classes have responsibility. For example, if I create a class called customer, so here I have a class called customer. I have another class over here called account. I have another class here called account, right? What is the relationship between a customer and account? For example, the customer here will open an account. The customer here will put his name and details here, but the relationship is that he would open an account. So I'll create an account class, holds everything about an account, but the account here is related to a customer. That's a customer has the responsibility to collaborate with a particular customer. So you can see here that here I have the responsibilities of the customer. The customer will open an account. He knows his name, he knows his address. And that means that the account number here will have to know when the customer wants to create an account. The account number here will go to the customer account and go and find this name from there. The account number here will go to the customer and go and pick its address. The account number, there's just the account number. You have your account name, balance, when you remove the money, when you didn't remove the money, it's saved there, fine. But when I come to you and I tell you account 444, whose account is this? You would have to go to the customers class and find out that, oh, which customer has an account called 444? That means that the responsibility of a customer to the account is that the account will open an account for him. The account can go into the customer and go and find out his name. The account can go into the customer and find out the address of the customer. When we come to the account itself, it has a responsibility with a class called manager. The manager will go to the account and know what is the interest rate we are giving this guy. Oh, what is his balance? How does he handle deposits? Should I report fraud on him? So these are the things in which the manager class can do in the account class. That's the account class has responsibility to the manager class to provide this set of information to it when it needs it, when it requires it. That means that when I'm coding, I have to code in such a way that the relationship would be done, that whenever the manager requests for information, he will get, and he will get these pieces of information when he requires. And this is the structural diagram that we use to showcase the responsibility of a class to another class. The class that has the responsibility would be here. Here we'll list the responsibilities. And over here, we'll have the collaborator, who it is collaborating with, who it is sharing information with. Are there any questions on this point? Scope and visibility. Scope and visibility. Whenever you are dealing with IT and they mention scope, it is a very
Sir,
yeah.
Sir, sorry to cut you, but a question was posted and then
in the chat. Oh, okay.
Yes, sir.
I haven't seen it. Sorry. I can't see the question from Hario. Okay, I can see the one message down. Yes, I can see it. So please, what will be the difference between an attribute and a responsibility? An attribute is information that I am saving about myself, my characteristics. For example, if I take a customer, I'll have customer name, customer phone number, customer email, customer address. These are information I am saving for myself. The responsibility is what kind of information can I offer to another class? So if I want I myself, I am holding my name and my address. Who can I give my name and my address to in my system? I can give my name and my address to a particular account alone. So it means that if a manager comes, he can't get access to my name and address. Only way for him to get access to my name and my address is to go through the what? Account. So the responsibility is the information I can offer and the services I can offer. So for each class, you have the what services can it offer to another class, and what information can it offer or take from another class. So in the example we saw above over here, we can see that the customer can offer opening of account. It's not a customer who opens an account. It is this guy who opens an account, the account class. So the account class, the relationship it has with the customer class, and it has the responsibility to open an account on behalf of the customer. Also, the customer can provide the name of the customer to the account. For example, when you go to the bank and then you say, oh, this is my account number, but I have gotten married, so I want to change the name. What name is there? I want to check. That means that the account class will go into the customer class, look for the account that has that customer on it, and pick up its name. That means the customer class can only offer the name of the customer to the account class. It can't offer it to anybody else. If we add manager here, then the manager can also go to the customer class and offer its name. Again, if you are someone who is seeing a bigger picture, you can see that this is how they manage rights and responsibilities in the system. So I can say account. That means if you're not an account, you don't have access. Manager. If you're not a manager, you don't have access. Sorry, my knowledge on banking is very, very poor, but the cashiers on the front desk, maybe I'll put the cashier here. So depending on who you put here, they can do this or they can get this kind of information from the customer. I hope I've answered your question, Harry. Now back here, yes, we have scope and visibility. The scope, whenever we say scope, is a very grievous word. It's a word in which students never understand how That word is protecting them. You see, for example, you people will be doing your final year project very soon, and some of you have already done it in the undergrad. When you are doing it, they will ask you, what is the scope of your work? And you say, oh, my work will encompass Blue Crest University. That means that if I come and ask you a question, so this work, I have seen it in VRA before. And in VRA, this is how it works. You, the student, you should have the courage and the wisdom to say, sir, please hold on. The scope of my work encompasses Blue Crest. So what you are saying is out of my scope. Right there, it's not challenge, because there's a reason why they call it project defense. You must defend. So right there is not you challenging. You are telling the person in the documentation, I said that my work will only, the environment my work will work in is Blue Crest and Blue Crest alone. You people accepted that my work should work in Blue Crest and Blue Crest alone. So if you are going outside of Blue Crest, you are out of my scope. Same way, visibility derives from the word how seen, or where should it be seen. So depending on where I am, who should be able to see me? Let us have a look at this in a very practical way and see how we can define those things. Over here, I have account. I'm going to remove the word private from here. I'm going to remove the word protected from here. I'm going to remove the word protected from here, and I'm going to remove the word protected from here. The moment I remove the words protected and private from here, I have just told the computer that the things I have here are all public. Public. Public means that when I come here, and let me remove all of these things here, and then let me remove this one too. I'm going to tell the computer system .out.println, or no, print is fine. So here, I'll put something in here to print. Over here, I'll tell the computer I have created a class called account. So I have an object called SA1. So SA1. In SA1, I have the ability to have, let me do it this way rather. Since we are dealing with account, let me deal with account alone first. So here I have account. I'll call it AC1. It's equal to new account. And in here, I'll put in the account holder's name. So here I have Mr. Harry. And then how much is Harry's balance? I think Harry, today being the 28th, payday drop. So Harry has 30,000 in his account. Harry, I think I'll come and visit you today so that we go to Osu to go and enjoy the money which you have. So here I have this amount of money. This is me constructing an account. So you can see that I've given it the name and the balance. Fine. So over here, when I say AC1 dot, give me the account holder's name, right? So, sorry, let me come in here. I've done this. Yes. So give me the account holder's name. I should be able to access the account holder's name from my system. Just like that. Why can I be able to handle, sorry, let me put in public here so that we remove any ambiguity from it. So space public, good. And over here to put public, and here to put public, And here will be public. Great. And then 5 users. Okay, the users are, the problem of the usage is coming from here. So let me remove, if I remove this, it will give me an error. If I remove this one here, it will give me an error. So you go away for now. And then you two go away for now. That there are no usages of this one related problem coming from here. And then what is the related problem? Let me see. Dots account name. Yeah, that's fine. Good. So you can see that when I bring the AC1 here, I can bring the dot. The dot tells me in AC1, these are the things you have. What do I have there? I have account holder name, I have the balance, I have the account number, I have the deposit. You can see that there's an M here showing it's a method. So I have the deposit, I have the account holder name, I have account number, I have transfer, I can do withdrawal. The computer also gives you all of these things as part of the object. So these are, they come automatically. So on the top here, I have the things I created. When I go to account, I can see account holder name, that I can see the methods I created to also showing for me. This should not be so. It is so because I told the computer that everything in which I have here at the top here is public. Now, if I make it private, so let's make it private. So here I remove this word here and I make it private. Over here, I remove this and make it private. Over here, I remove this and make it private. And I remove this one too and make it private. Now, once I do that and I come here and I bring my dot again, I cannot see account holder name and all of those information. I can only see the methods. I can see the methods because the methods are what? Public. The private ones are hidden. Let's define what public and private is now. When something is public, it means that another class can have access to it. So it is public to other classes. When something is private, it means that it is private from other classes, which means other classes cannot have direct access to it. That is why over here, for you to get the account holder's name, you have to go through get account holder, which is a method. Now, when you go through this, then we can say, okay, the person's account is what? That. So if I'm to run this code here right now, I'm supposed to get on my screen the answer of Harry. Where I have saved Harry, you, the user who uses that application, should never get access to where I have saved Harry, where, who, what Harry is. It will give me errors because I've removed the extended from here, but there would have just displayed that just so that I can show you guys. Where, who, what Harry is saved, how he is saved, where he is saved. Do we save him twice? Do we save him once? All of that information, you, the main class, do not need to have access to that. All you need to do is go through, get holder username, and you will get your information you want. But the innermost feelings of you, the characteristics of you, we are hiding all of them as private. That means that visibly, it is not visible to you, the main account. You can't see it. So when I come to main account, I showed you this practically. When I come to main account and I tell the computer, okay, if you have AC1, I want to see the things in it. I can't see it. It is not visible to me because I've made it what? Private. Now there is a problem with private. Private means that I can't have access to it. Me. I can't have access to it if I am another class. So if I am another class, I can't have access to it. The only way I can have access to it is if I am public. So looking at this again, you can see that over here I have 3 related problems. What are the related problems? When I come over here, it is red. You can see them. The balance is red because I am trying to have access to balance, but the balance I'm trying to have access to is private. The checking account here is another class, so I can't have access to something which belongs to this class because it is private. But I should be able to have access to it. Why? Because the checking account here is a child of account. That is extends account. So it is a child of it. So I would not use the word private here. I would use the word protected. Now, the moment I use the word protected, you can see that the balance down here is no more red. Hence, what does protected mean? Protected means that another class cannot see it. The only way that other class can see it is if it is a child of that class. So you can see that account here has a child called checking account. How do I know it is a child? I can see it extends from what? Account. So checking account extends from account. Account is the parent. Checking account is the child. Hence, for you to have access, I'll make it protected so that the children of the account called, the children of the parent called account can have access to its information. The moment I change this to private, it means that its children, even its children, do not have access to it. Because I'm telling you, hey, don't let any other class have access to this piece of information. Let's do a quick recap. If it is public, other classes can have access to your information. If it is private, no other class can have access to your information. If it is public, no other class can have access to your information. Only way they can have access to your information is if they are your child, period. So this entire slide here is talking about that. When do we make something public? When do we make something private? When do we make something protected? When you make it private, when you make it protected, what does it do? Now, when you are drawing your diagrams, if something is private, then you use the plus. If something is protected, then you use the minus. If something is, if something is public, you use the plus. If something is private, you use the minus. If something is protected, then you use the hash symbol. So over here, we can see we have frame, and in frame, we have plus, add a message, which means it's public, hash set check sub, which means it is protected, and we have minus minus here, which means those things are what? Private. So in your exam, I can tell you, create a method and then indicate elements which are private, protected, and then public. Technically, it means you need to create methods and decide which methods are going to have a plus for public, a minus for private, and a hash for what? Protected. Again, let's pause here. Any questions?
So, sir,
With
the question you asked, does it mean you have to draw the diagram for the candidate?
Does it mean that you have to draw the diagram?
Yes, create a method and indicate private, public, or protected.
Yes, you would create a method and indicate if it is private, protected, and then that.
So we will draw something that can be seen on the screen.
You will draw something. You will draw the class diagram.
I mean, yeah.
Yeah, you draw the class diagram. For example, if you check your module, you see that your assignment 1 has been placed there. So the assignment 1 you are supposed to do for this semester has been placed there already for you. I have a copy of it over here, but when you go to your module, you will have it there. You see that in there you have questions, and over here I said, design the class diagram and the use case diagram for the following 4 use cases using an object-oriented approach. So your job is to draw the diagrams, show the relationship between the diagrams, indicate which one is public, private, whatever. If you want to put inheritance, you can. If you want to do encapsulation, you can. And demonstrate them using the diagram. The arrow shows you relationship. So for example, if I draw an arrow from here to here, it shows the relationship between this and that and this and that. The arrow would tell us what relationship you have. So for example, if I was to draw the diagram for the scenario we have that has to do with the account, I will draw a square, and then I'll draw another class diagram, and I'll use the arrow to show the relationship, to show, okay, from this window to this event, this is the relationship they have between the two. This is a more realistic diagram, which I would expect from you. So we have a diagram from here to here, that to that, that to that, that to that, and so on and so forth. I think from next week going, we will start writing Java code as well, so that we would see how most of the things we do are practically done. And then also we would have the hands-on knowledge to say, okay, this diagram, I'm doing it this way because of this effect, and so on and so forth. So from next week, we will start building Java applications. I sent you people videos on Java. Did you watch them? Or because of work, there's no time? Were you able to watch the videos I sent on Java programming?
Yeah,
Yes,
watch a bit.
Okay. Now, we are going to discuss use case diagrams. We utilize use case diagrams to look at the behavior of particular elements in our application and what they will do in our environment. What are the things they will do? For example, let's have a question that utilizes the use case diagram, and then we would build the use case diagram together to show what we mean when we say an actor, a use case, a system. Does it include, does it extend? Let's see what we would do in these scenarios. I'd like one person to read what is on the screen for us. Let me bring up what is on the screen. So I have this scenario. One individual should read it for us.
Okay, so scenario. Online food delivery application. You have been hired to design a use case diagram for an online food delivery application similar to apps like Uber Eats or DoorDash. The system should allow customers to browse restaurants, view menus, place orders, make payments, and track the delivery status. There are 3 types of users: customer, restaurant, and delivery person. Customer. A customer can browse through different restaurants, view their menus, add items to the cart, place an order, make payments, and track their order in real time. Restaurants. A restaurant can manage its menu. That is, add, remove, or update items, receive orders, and confirm order preparation. Delivery person. A delivery person can accept delivery requests, view the order details, pick up the order from the restaurant, and deliver it to the customer. There is also an admin who can manage user accounts. Example, customer, restaurant, delivery person, and monitor the overall system. Task. Identify the actors in the system. Identify the major use cases for each actor. Draw a use case diagram based on the actors and use cases identified.
Okay. Take a minute. Tell me the first point. Who are the actors in the system?
Please, I think we have the restaurant, we have the delivery guy, and then we have the customer.
Perfect. So these are the actors of the system, right? Okay.
Yes, sir.
Point 2. Anybody who does not understand how we got those people as actors. Note that the normal rules apply when you are teaching, whereby the teacher will do the simple one, then the students will go and do the hard one. So this one, luckily for you, it is easy for you to identify the users, because of course I have stated what the users are. In questions which will come to you, I would hide them. I would not show them. Do you understand? So it is upon you to identify the actors who play a role in the system based on the scenario created. And the honest truth, in our workplaces, in our daily life, no one will come and give us the question and say, oh, these are the actors. No, 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 no. Especially when you have a conversation with someone for a job. The person, for example, this woman who sells rubber bag, the black rubber bag in Accra, and she has a big warehouse, and they supply almost 40 to 50% of the rubber bags in Accra. Very, very lucrative. I didn't even think of that. I would have stopped school and go and sell rubber bag, but I didn't think of that. So she wants a system where when people come, they can buy the rubber bag, but they would pay for it at one place and go and pick up the rubber bags at another place, and someone else will check. So they want a system where when they come, someone will just click on a button, enter the rubber bags you are buying, click yes. When you go to the next place, you will check the system, click. When you go to the next place, you also enter and click. But the problem is the people don't have desk and things, so they want it like an app, so that the girls will be fast, and when they click, the order will come and the person can just pick up the orders and all of those things. In a scenario like that, the person is narrating the thing. I am even narrating it in English. The person was narrating it in Tree. Oh, me pede way, your job is to sit down and come up with the actors and people who play a role in that. In your workplaces, you watch people do things of the business processes every day. They do one thing after the another thing after another thing after another thing. Your job is to watch the people who do those things, come up with who is relevant to it, who is not relevant to it. And the people who are relevant, you build a system around them. The use case diagram allows us to know who is who in our system and what do they do specifically. If they do nothing, they remove them from the coding process because they're not supposed to be there. So in the design of your system, from here, I'll pick this, I'll drop it here, and this here becomes my environment. So over here, we have what the system we are developing, what is it called? A food delivery system. So over here, I have online food delivery. So in here, I have online food delivery. Boom. I'm done. Now, next question. Who are the actors? So here I have an actor. He's going to serve as my customer. Over here, I have an actor. He's going to serve as my restaurant. And then finally, I have another actor. And what is that actor? He's going to serve as the delivery person. So here I have another actor. And that actor is going to serve as my delivery person. Sorry. Now, the next question is asking. Sorry. The next question is asking. Identify the major cases for each actor. So who can tell me what are the major cases for each actor? So let's start with customer. What can the customer do?
Sir, please, can we go to the scenario again where the customer is? Yeah, okay.
Okay.
So the customer can browse through different restaurants and then view their menus.
Okay.
You can also add items to his carts.
Okay.
He can place an order.
Okay.
He can make payments.
Okay.
And he can also track his order.
Okay.
Yeah.
Okay. Now, you see the way you said everything over here. Great.
Yes.
Now, what is there that we have to add? Since the customer is coming to use the system, should he be able to register and log in?
Yes, please. He should have his registration details.
All right. And then since the person is going to do food and stuff, should he be able to give feedback? So you say, oh, the food is not nice. And then can he do that too?
He should be able to do that.
Okay. So we have added those things to the things which are not here.
Yes.
So now, how will I put this together? How will I draw this? So over here, I'll come and click here. I'll click here. In here, I would go and pick this oval thing. And in here, I'll put in login and registration. I will stretch it, and then I will drop it into the middle. Now, why am I putting it into the middle? Because this person here would be able to log in and register. This person here should be able to log in and register. And obviously, our customer will also be able to what? Log in and register. I'll bring this here. And then I'll bring this one down a bit so that it can cover. Great. And then this one should go up a bit. Sorry, it should go up a bit. So it goes over here somewhere. So I have this. Now we're also saying that the application should have the ability to view the menu. So we can scroll down here. I'll come down here. And here I'll say view menu. So we can view the menu. I'll click here. I'll come over here. I'll scroll this one down. I'll come here. It said we are able to add items, right? So here I'll click here and say add item. Let me make it a bit smaller. I hope we get a picture. Hello? The restaurant, he should be able to log in. He'll be able to manage the menu. So over here I have manage menu. We want to do this in such a way that they don't touch. So here you'd be able to manage the menu. Over here, this one would be able to do this, and he will also be able to do that, and he should be like that. So whenever we are doing the use case, we'll put in the cases over here, we will list them, we'll determine what each and every single actor is supposed to do. Note that some of the activities that the actors will be able to do would cross. For example, register, all of them can register. Sometimes all of them can view orders, view this. Some of them can do common things together. The key of this diagram is to help us to know what each person will be doing in the system or can do. Note that the things they can do is what you would take and write as your methods and your functions in your class diagram. So when I take customer, register, add, do this. Those are the methods they will do. So this diagram will help you to know the specific things that the various entities here would do, helping you in the class diagram design. Here, we are looking at behavioral. The customer can do this. The customer will be able to view this. These are behaviors that they will do. So this is a behavioral UML. When you are done drawing the diagram, and I'm not done drawing the diagram, you would copy the diagram. Yes. I'm listening. Please talk.
Okay. So what we are doing now, is there a difference between the UML and then the flowchart?
Oh, there's a huge difference between the UML and the flowchart. The flowchart, you are looking at one process. So under the flowchart, I would say, okay, when I take viewing the menu, what will happen under viewing the menu? The person will start. When they start, the person would go and is viewing the menu. So the person will start, the person will click on view menu. If there will be a decision, if item in view menu, then the person can now go and what? View the menu. Now, if the person clicks on item, then the person can take it to the checkout box or whatever you want to do. One thing students do, whenever you watch a student's project work and they do, is that their flow chart will be the entire system. You can't do a flow chart of the entire system. A flow chart of the entire system is impossible. A flow chart is done for a particular process. So when you people were doing your undergrad and when doing flow chart, technically you cannot have one flow chart diagram. You should have at least 4 or 5 or 6, showing each process differently. So the flow chart is for a process: logging in, registration, buying an item, viewing an item, viewing the menu, receiving orders. You will do a flow chart for each of these items. You remember when I was talking earlier, I said that the method when we click it to go and do particular actions. Whatever actions which will be done, that one will determine it later. I said that. That is the flow chart. The items that will be done in there. Oh, step 1, I'll do this. Step 2, I'll do this. Step 3, I'll do this. That is the flow chart. The use case diagram is saying, this is my entire system. When you take this person, this is what he can do. When you take this person, this is what he can do. When you take that person, what he can do. So the use case diagram can be done of the entire system, showcasing what each person can do. Now, the flow chart will take each of the items here and tell you specifically what they will do to achieve that. Is that okay? The person who asked the question.
Sir. But I think there is a question statement in the chat, so you kindly check that for us.
Oh, okay. Sir, please, can we have some hard ones for practice? Once go through this straightforward. Yes, you would have examples to go and practice with. I'll send you some examples to go and practice with. I want us to understand everything first, so that when I give it to you, you will not go and struggle. Is that okay? So once you are done drawing your diagram like this, you would export your diagram. So have I even already exported it? I thought I was doing that well. Yes, I have. So it is here. So I would export the diagram. Copy. And then I will take the diagram I have exported and go and put it in Word. So here I'm putting the diagram in Word. Then over here I'll say, oh, let me cut this out. I'll say use case diagram for restaurant application, where is it? Food delivery application. And then I'll paste the diagram in which I want to take over here nicely. Then under here, under the diagram, I will put in there the various definitions of the use case. For example, when I take a customer, this is what he or she can do. One second. So over here, I'll say under here, I'll say, if you have a customer, these are the things you can do. If you have a restaurant, These are the things you can do. And you can see that with each one, I'll specify directly what they can do. They can register and log into the system. But on the use case, I will not write this entire statement. I only write manage menu. The use cases are written as an adjective. So manage revenue, confirm order, do this, do that, like that. Short. Register, view all them items, so and so. Now, also, because on the menu there, they didn't write admin, you didn't add admin as one of the users. I also didn't say anything because I wanted to get to this point. There may be hidden users that are not in the question, because all of them will have to be managed by the admin. He is the one who will monitor everybody. He's the one who's going to check if your account is created and update it and do all of those things. So he has to be part of the system. So it's not just you draw the diagram and you leave it there. You send, well, when I give you a sign, you just draw the diagram and you send it, say, this is the diagram. No. You draw the diagram and under it, you say, okay, register, it is the customer who does that. Register, he will do this, he will do that, like this. Again, we go back to the first lesson where we dealt with identifying the players and the actors. You must be able, for you to be great at coding, for you to be great at data analysis, for you to be great at database management, you must be able to identify people in the crowd. When you identify them, you must be able to group them by giving them attributes and classes. If you are in a school and you're sitting down, okay, these are all lecturers. Why are all of these people lecturers? What makes this person a lecturer? Oh, these are all admin staff. What makes these people admin staff? These are all people management. What makes them management? These are all lecturers. These are all students. What makes this one a postgrad? What makes this one a pre-university? What makes this one a university, a postgraduate student, an undergraduate student, a pre-university student? What makes them different? The use case will tell you, what do they do? The what do they do would be your function. And this comes to the questioning when someone asked earlier in our class that, can you have a class without a method? You can see that here, technically, the customer is now my class name. So the customer will say name, that. The customer can register, browse, do this, do that. These are the actions he can do. So if you have a particular actor and he plays no role in your environment, to be honest with you, most of the time in coding, you remove them. When you go to the bank, somebody who works in the bank that is always there whenever you go is the security person. Does the bank system that does your payment, does it care about the security person? No. The security person does not matter in that environment. He matters in the banking environment. But when we narrow down to payments, deposits, accounts, creation, withdrawals, transfer of money, the security man doesn't play a role there. It is you, the experience manager, and then the bank. In the bank, what specifically in the bank? The account? Is it checking? Is it savings? Do you separate them? Do you make them one? These are questions in which you have to answer. I can't answer it for you. That is why whenever you have a system and someone else to build, you realize the system is different for every individual, because the way I will see it is different from the way you see it. Note, there is a way in which is better. So the fact that you see it this way doesn't mean yours is better. Let's be honest. So the job of this course is to take your way, is to help you design your way, is to help you design your way in the object-oriented way. And once you're in the object-oriented way, Then we'll look at how to make it better, how to make it more efficient. Today, our main aim was to focus on the diagram. How do they look? How do they feel? How do they come about? Which portions do we note? How do you make relationships between them? And also to learn basically what the use case diagram is, how do you utilize it, so on and so forth. The slides will come, you'll be able to read and get more information on them. But the key points are, I must be able to look at the system, look at the scenario, identify who plays the role, what information do I keep, how do I group them? Because in grouping them is me creating the characteristics. The characteristics will become my variables. In me knowing what they do, those will become the methods. The methods is what I'll write as the function. These are things in which you should be able to identify and utilize. When we come next week, we will start adding a bit of coding to what we will do. So we will take a question next week. We'll break the question down together. We'll write the diagram together. And then we'll write the Java code for it together so that we will see how we can take a problem, create a solution, and manifest the solution. And then we'll also learn how to deploy the solution, all using the object-oriented way. And in that class,
should we all get the same IDE?
That would be best. I'm using IntelliJ as my IDE. You can use the educational or community edition, but it depends on you.
Okay.
So as I said, we will learn how to deploy the application too, all using the object-oriented way. And in that class, we would focus on requirement gathering. So next week, I'll focus on the requirement gathering. How do I see the problems? How do I identify this is the player? How do I identify that this person can do this and that? How do I gather that piece of information and utilize? We'll take a question and we'll go through the process of me identifying the requirements I need. So that when you're on your own and you're faced with a problem, you know that this is how I can identify and gather the requirements I need to build my system. I know not all of you are programmers in Java and programming, and not all of you like programming. So in your exam, to be honest with you, there would not be a lot of programming questions there. There will be more on diagrams, requirements, do this, implementation. Are we okay? But the key point is this. The reason we are learning the code is to help us to see or visualize what we are doing on the diagram. How will it be like in the real world? That's the only reason why we are doing it. So for those of you who cannot code, try, but don't run away because we are doing code. Someone in the undergrad should stop the school because her first class was maths and her second class was coding, and she realized that the IT are not just going to do Word and Excel, so she stopped. Please don't do that. It gets easier. Are we okay? Before I bid you farewell and allow you to go and enjoy your weekend, are there any questions?
What is the deadline for submission of the assignment?
I think it is 1 week, but I think you people, yours is supposed to start next week. So I will extend the time and do it 2 weeks. So you have 2 weeks to submit.
Okay. Okay. So you say we should expect more diagrams in the end of SEM. And what of the mid-SEM?
When we get there, we'll discuss them mid-SEM. Don't worry.
Okay, sir. Okay. All right.
Oh, we'll discuss each one before you go and write. I won't just tell you to go and write.
Okay.
If I do that, I'm being
okay, sir. Okay, sir. Okay.
Don't worry, the exam and things you'll be fine. Let's just focus on knowing what we are doing. Is that okay?
Okay.
Thank you all for coming today. We'll meet again next week.
Thank you, sir.
I think we have to meet on campus, so we'll discuss that later. But next week we'll do it online.
and then we'll all meet again next week. Bye-bye.
Okay, sir. Okay. Thank you.